Welcome to Graphiti, a Ruby solution for graph APIs. Graphiti can be added to any existing Rails project, so we'll start with a few models already defined for us. An employee has many positions, each position belongs to a department. We need to expose these models to the API, and to do that we'll run our resource generator. Resources are an interface around query and persistence operations. Let's use Vandal, the Graphiti UI, to see what we get out of the box. We can filter our data by any attribute combined with an operator. Operators are things like prefix and suffix for strings or greater than, less than for numbers. Here we're finding all employees with the first name starting with the letter A with an age greater than 30. We can sort by any attribute as well, ascending or descending. We can even sort by multiple properties if we need to. Of course, we'll have to paginate at some point, and we can do that with the current page and per page parameters. Let's say limit 2. Oh, and we can say that we only want a specific set of fields to be returned in the response. Now, nothing crazy is happening here, just a simple HTTP call returning JSON. We can even open up a console and curl it directly. Now, the word graph is in the name of our project, so let's get to associations. Our employee has many positions. Positions belong to a department. We'll run our generator for those as well, and we'll get all the same functionality we just went over. Then we'll need to tell Graphiti about these associations, just like we would when adding associations to our models. If model relies on a foreign key, we'll add a one-off filter-only attribute for it. Now when we use Vandal, we'll see relationships that we can add, pulling back all of that data in a single request. I can see that Scotty here was a construction assistant before he was a national developer in the QA department. We can apply the same query logic to any level of the graph, like saying that we only want active positions to come back in this request. We'll call this deep querying. You can view all this in a nice little JSON snippet for readability, though by default we render to the JSON API specification. You can tweak this on the fly by adding .json to the URL, getting back a simple nested structure instead. We got an auto-generated schema for free as well, complete with types and backwards compatibility checks. We generated end-to-end integration tests validating all this behavior, as well as patterns that allow us to deal with errors in a consistent way. Same functionality can be written for any ORM or data store. We can blend SQL, NoSQL, external service calls, and whatever else. To explain how all this works, we need to talk about REST. REST means many things to many people, but fundamentally it's about transferring state. Let's start with an employee resource. Let's call her Jane. We transfer this state from the server to the client. The client possibly modifies that state, let's rename her Janice, and to persist this change, we just move the resource back to the server. Graphiti is about making this concept a first-class citizen. A resource class is an interface for query and persistence operations. Resources can run in any plain.rb file. There's no Rails dependency, and we don't even need a web server. The class accepts a payload that matches query parameters, and we can return JSON or the underlying model instances themselves. When moving state to the server, we can rebuild these resources and easily persist them, complete with transactions and validation errors. That brings us to the other important concept of REST, which is links. Links hold the logic connecting resources to each other. Links are useful for discoverability, but more importantly, they give us the ability to lazy load data. We can fetch the employee first, then each association just by following a URL. This is important because those URLs hold query logic that connects resources. This means that we can update that logic server-side without breaking clients. The premise is similar to .includes with Active Record. Fetch all the employees, then fetch all positions with an employee ID in that list. Here's the cool part. That logic can be used when we're lazy loading data, breaking apart slow requests and fetching each relationship one by one, but it also applies to eager loading. Graphiti adds eager loading to REST and eager persisting. We can read and write a graph of data in a single request, breaking it apart however we'd like. Let's dig deeper into the lifecycle of a request. When a request comes into an API endpoint, it's passed to a resource. That resource performs query building, figuring out how to transform that request into something a given backend supports. A resource can work with any backend, it just needs to return models which hold business logic. Those models are then serialized back in the response where we can tweak presentation logic and even adjust the structure of the payload at runtime based on content type. Let's dive deeper into query building. If you were to code a dynamic API by hand, you'd end up with something like this. Start with the base scope, and if the first name parameter comes in, modify that scope. If the sort parameter, etc. Finally, fire the query and return models. This pattern isn't limited to Active Record. The same pattern could build up a simple Ruby hash and pass it off to an HTTP client. If the filter, modify the hash, and so forth. At the end, you'd want to take the raw service result and build up model instances from the response. Resources extract this pattern into a DSL that's reusable across endpoints, taking into account things like type coercion and error handling for you. As you can see, the same logic would repeat for all Active Record resources, so we can package it up into an adapter, leaving us with nothing more than declaring the attribute and its type. That's why the employee resource does so much but looks so simple. By leveraging conventions, we can remove boilerplate and be left with just the parts that we care about. Because all of this is just a normal HTTP call, we don't need anything more than a simple fetch to grab the data and easily render it. Code like this would work in any modern client-side framework with no dependencies. But if you're looking for a more robust client, check out Spray Paint, aka Active Record in the browser. Modern apps treat the API layer like a database. You know what's been a wildly successful abstraction around the database? Active Record. Here we're building up a scope and returning model instances just like we would on the server, but we generate a promise that executes an HTTP call instead of a SQL query. This can be tremendously helpful when dealing with form bindings, error handling, and state management. And it'll be familiar to anyone who's used Active Record before. Okay, last concept. We know that resources connect together with links which hold query logic used for lazy and eager loading. We can follow these links when lazy loading or automatically execute the request when eager loading. This means that resources don't need to be local to the same application. We can have remote resources in different APIs just by following the same basic pattern. And if I make these super small, I guess I can call them microservices. Sound cutting edge. Let's wrap up with some actual features. To start, we'll be finding coworkers and the bugs assigned to them. To do this, we'll work off of Graffiti's completed employee directory sample application. Feel free to visit our website and follow the step-by-step tutorial to fill in any missing gaps. We'll start with the employee show endpoint because we're finding coworkers for a specific employee. Let's take Scotty here with the ID of 1. Employees belong to a team, so let's grab it and all the other employees associated within that team. The only problem here is that Scotty is coming back in the list as well. He can't be his own coworker. So let's add an ID not equals to filter to make sure that Scotty doesn't come back in that list. And now we're only going to see his coworkers. Let's grab the bugs for those coworkers. Bugs are a type of task. This is like single table inheritance. Think of a table with a type column. We're going to say, find me all tasks with a type of bug. So if we select the coworker named Mercy, we can now see all the bugs assigned to her, and here it is in a nice little JSON snapshot. There is an issue here though. We're finding all the coworkers, not just the ones assigned bugs. So Corey here should not be coming back in the list. Let's go to the server and implement that feature. We're going to have to add a custom filter, so we'll start with our resource spec, which you'll see whenever you run the resource generator. We're going to add a filter called debugging. It'll be a boolean. Here I'm setting up that filter just like I would in an actual request, and I'll start by seeding some data. Let's create 2 employees and make sure that only one of them has a bug assigned. We'll use a special method called records to fire the query and get back model instances. And we'll say that the result should be employee 2, the only employee that has a bug assigned. You'll find a ton of specs in Graffiti that follow the same basic pattern. Now, this will fail because we haven't implemented anything yet, but it'll be a helpful failure. It'll tell us that attribute debugging doesn't exist, so we can't filter on it. Let's go ahead and implement that now. This is a filter-only attribute, so we'll say filter, specifying that its type is boolean, and we'll modify the scope to join against bugs. That way only employees assigned bugs come back. And now our test passes. It's that easy. Now, I actually don't care about the false scenario here, so I'll say to only allow true so I don't have to deal with it. You'll see if I did pass false, I'll get a helpful error there as well. It'll tell me that only true is allowed. Now this part is not even necessary. You can develop in Graffiti without opening a browser at all. But to just double check, let's pass our debugging true filter to make sure that only employees assigned bugs are going to come back in the response. That's actually it. We've implemented our feature. When we pass debugging true, Corey no longer comes back. Okay, next up we're going to find bug stompers for a team. Now this is a domain-specific concept. It's something that my business wants to iterate on over time, and no client should have to update when we change that business logic. I'm going to start by defining a relationship. It's going to be called bug stompers, and I'll write a test very similar to what I did last time. The important thing here is that we're going to have to set up our relationship in such a way that whether we eager load this data and get everything in a single request, or lazy load this data and do multiple requests, that I always get the same data back. Both use cases are valid and important. Breaking apart huge requests is a great way to improve performance. When seeding data, I'll make sure that only employee 2 is on the right team with bugs assigned to them. I'll use this sideload method to grab the related objects from the response, look at the IDs, and then ensure that only employee 2 is coming back. Now, I haven't implemented this yet, so it's going to tell me that bug stompers is not supported. This is a many-to-many relationship, so let's add that now. There are a few ways that we can do this, but I'll just use the as keyword to let Active Record do the heavy lifting, figuring out the right joins and foreign keys. Now the trick here is actually the params block. This can add whatever query parameters we want when we're fetching the association. So I've added the debugging filter we implemented earlier. And now our test passes because we're reusing the same logic. So now if I look at engineering team B and I say to get the employees, I'll see everybody. But if I say to just get the bug stompers, then Corey is not going to come back because he wasn't assigned any bugs. Looking at the raw response, we'll find links that clients can follow to lazy load the same data. Clients can simply follow these links instead of assembling the query themselves. That means that we can break up large, slow requests into critical data that we need up front and less critical data that can be deferred for performance reasons. And we can add whatever query parameters we want to here. Maybe next sprint we'll say that only engineers can be bug stompers, or there has to be a certain bug severity level. We have to have knocked out 5 in the last week, whatever. We can iterate on this without breaking clients. So last up, we're going to implement a search feature. This means that we won't be able to use the active record default. We'll change things up and issue an HTTP call. We'll do this using Elasticsearch, and we can use any client, but for this demo we're going to use SearchKick, an Elasticsearch client from Instacart that I highly recommend. SearchKick will return active record models, but you could eliminate active record altogether and return plain old Ruby objects if you wanted. To start, we'll need to add the SearchKick gem to our gem file, make sure that's installed, then go to our active record model because SearchKick ties into our models. The word middle logic here determines what matches I'll get in my response, and the attributes method specifies all the fields that we want to put into the search index. We also need to wipe the search index after each test, just like we wipe the database after each test. Now we can start coding. We'll start with a test again, and you'll see that there's nothing special about this test, even though we're dealing with Elastic. We'll end up using factories to ensure that the same code syncs data to the Elasticsearch index whenever we call create. We'll add the keywords parameter. There's our word middle logic. We want all tasks containing the string oral, which means that in this case only task 2 should come back. Now let's run the test and we'll see that the keywords filter doesn't exist, so we'll have to implement that next. We could do this as a one-off, but let's say that this isn't the only feature using Elasticsearch. Let's say that we want the same default query logic to apply whenever we're using Elastic, and we can always override those defaults. We specify that common reusable logic in an adapter, which is really nothing more than a handful of methods, how to modify the scope when we filter, sort, paginate, etc. Here we're modifying a simple Ruby hash, then passing off that hash to the SearchKick client. The client issues the HTTP call to Elastic and returns model instances. That means that our resource just needs configuration. We need to tell it to allow querying on a keywords filter. I'll say only EQ here, since things like prefix and suffix don't make sense for a keywords filter, and that's really the only code that we need to make this work in development. We do see test failures because of what I mentioned before. We need to make sure our factories update the search index. We'll do this with an after create hook. Check out the SearchKick documentation for a variety of ways to do this. Now our tests pass. Not just the keywords filter, but tests for sorting, pagination, relationships, and so forth. We're just reusing the logic specified by the adapter. Check out the logs here on the left-hand side for the actual Elasticsearch request, and note that we get all the same functionality as before. We can even add relationships, blending Elasticsearch and SQL in a single request. It's important to note again that functionality can be reused across endpoints, not just when I'm hitting tasks directly, but even in our original scenario of looking at a coworker's bugs. I can look at all of Anna's bugs, but I can also filter them by keyword. The exact same logic applies, and we can replace Elastic with Solar a year from now without breaking our API contract. And that is Graphiti, first-class RESTful resources. There's so much more that we haven't talked about though. Please visit our website at www.graphiti.dev or say hi to me at RichMoJ on Twitter. Thanks for watching.